Okay, and we have our second distance speed time problem. Homer walked from the power plant to Moe's Tavern at a rate, so this is our speed, of 9 kilometers per hour. Then he traveled from Moe's to home at a rate of 4 kilometers per hour. He walked for a total of 50 minutes and traveled 5 kilometers. How far is it from the power plant to Moe's Tavern? So we have a chart that we could set up again. Why don't you take a moment, put me on pause, and try that. Okay, so if I create a chart, I want distance and speed and time. And then we've got two parts to this. The one part is talking about going from the power plant to Moe's. So power plant to Moe's. And then we've got Moe's to home. And we, of course, still have some total values that are coming up in the description here. So total. So our speed, he's traveling at a rate of 9 kilometers per hour from the power plant to Moe's, so that would be the 9 going in here. And he traveled from Moe's to home at a rate of 4, so that would go here under the speed column. And he walked for a total of 50 minutes. Now we have to be careful here because our speed is given in kilometers per hour, but then we have this 50 minutes, and that's less than 1 hour. That's really 50 minutes. That's just supposed to be an arrow pointing over to here. 50 minutes out of a total possible 60 minutes in an hour. So that's really 5/6 of 1 hour. Okay, so 5/6 of an hour is his total walking time here. And I'm not going to change that into a decimal because it does give us a repeating decimal, and it's not great to work with. 5/6 is exact, so I'll leave it like that. He also traveled a total of 5 kilometers. So we have that. And then it's how far is it from the power plant to Moe's Tavern? You've got a couple of options here. You could choose to let your variables be the time, and then your distance is just speed times time. Or, because it's asking how far is it from the power plant, you could let your distance be your variables. So we could have our x and our y here, but then our time is going to end up being fractions because we know distance, or time is equal to distance divided by speed. So this is one model. You could do time is equal to distance divided by speed. So that'll be x over 9 for that one. And then Moe's to home, that one would be y divided by 4. Okay, so different options, different ways to do this. I'll stick with this method, but we could also do it the other method. Now, as far as equations go, we've got one equation with a total, so we're adding those together, and we have a second equation where we've got a total that we're adding things together. So our x plus our y has to equal 5 kilometers. And then the time spent going to Moe's from the power plant plus the time spent going from Moe's to home would have to equal 5/6 of an hour. So this gives us an equation here that has fractions in it. Now thankfully Desmos doesn't have a problem with fractions and it can handle that. So you can put that into Desmos and solve for your solution. We will eventually solve these algebraically. So we'll have to remember our fraction rules in terms of solving equations. We could multiply every term here by the common denominator to eliminate our fraction. And I just realized I have a little right-o. It's not a typo because I wrote it, I didn't type it. You might see right here, I put x instead of y. So I'll just fix that right now. That's supposed to be a y, not an x on the top of that one, but the first one is an x there. So we're going to learn how to solve these algebraically very soon, and while it's not as easy as Desmos doing the graphing, we still need to learn those algebra skills to be able to solve systems of equations. It's part of our curriculum expectations. To put that into Desmos, solve it, write a therefore statement. And when I put that in Desmos, I got an ordered pair of 3, 2. So we were asked for the power plant to Moe's Tavern, that's the x, and the x was the 3, so therefore the power plant and Moe's Tavern are 3 kilometers apart.